Students, welcome to my YouTube channel. In this video lecture, we are going to solve all the questions from time chapter in Keith Williams' General Navigation book. So let's begin with question number 1. Objective theoretical question. In which months is the difference between apparent noon and mean noon the greatest? So the two months are November and February. It is given in time part 1 chapter from Oxford book. So the November and February are 2 months when the difference between apparent noon and mean noon will be the greatest. Now what is apparent noon? Apparent noon is with respect to the real sun in the solar system. Okay. Mean noon, on the contrary, mean noon is an imaginary sun in your watch. That is, watch now in your watch the time is for 24 hours, right? So mean sun is with respect to imaginary sun in your watch. Now, when you maintain or when you follow time according to apparent solar day or apparent sun, the duration of a day, sometimes it can be 24 hours, it can be more than 24 hours, less than 24 hours. So to maintain uniformity and constancy, we do not use apparent sun, but we follow mean sun. Okay, and therefore we have every day 24 hours. Okay, 24 hours of day every day throughout 365 days for a year. So imaginary sun in your watch. Okay, so the difference between them is called equation of time, and it happens in the months of Feb and November when the maximum difference is achieved. Okay, and to compensate for these changes between apparent day and mean day, we have a leap year where we make this compensation between the difference in time of apparent noon and mean noon. So remember this. Next, question number 2. What is the reason for seasonal changes in climate? Why do we get seasons on the earth? So because the earth's spin axis is inclined to the plane of its orbit around the sun, because the distance between the earth and the sun changes, because the earth's orbital speed around the sun varies according to the time of the year, because of the difference between the tropical year and calendar year. So what is the correct answer? So correct answer is option A. We get seasons on the earth because the axis of the earth, let's say this is the axis of the earth, this is the elliptical orbit of the earth around the, so this is the earth and this is the elliptical orbit of the earth around the sun. Now, axis of the earth, okay, now you can see the axis of the earth is inclined to this elliptical orbit. Okay, it looks something like this. This is your elliptical orbit, then this will be the earth, and this will be the axis of it. So, this is the normal. Okay, so the difference between them, the axis of the earth and this elliptical orbit, is 66 degree. Okay, and due to this inclination of the axis of the earth with the elliptical orbit of the sun, we get different seasons in a year, because when the earth is closest to the sun, what hemisphere will be exposed? The southern hemisphere will be exposed to the sun. When the earth moves far away from the sun, like this, What hemisphere gets exposed to the sun? The northern hemisphere gets exposed to the sun. So we have, when southern hemisphere is exposed to the sun, we have winters in the northern hemisphere, summers in the southern hemisphere. When the north hemisphere gets exposed to the sun, we have summers in the north and winters in the south. So this is how we get seasons, because of inclination of the orbit and axis. Next, question number 3. How would you define standard time in relation to UTC? It's a local time. It's a local time adjusted to whole or half hour's difference from UTC. It is based on local sunrise and sunset. It is another term for UTC. So this is wrong. Another term for UTC is GMT, Greenwich Meridian Time. It is based on local sunrise sunset, wrong. It is local time adjusted to whole or half hour's difference from UTC, or it is simply local time. So correct option will be option A. Standard time is nothing but the time, the time kept or the time followed in one country. Now, a country will have many longitudes passing through it. Let's take an example for India. Let's say this is your India. Okay. Now there are many longitudes passing through our country, and every longitude will have its own LMT time, local meridian time, right? So to maintain uniformity and convenience for administrative purposes, we need one constant time that will be followed by all Indians or all residents in the country of India, in India. Therefore, from all the longitudes that pass through this country, we pick one longitude and make that longitude the reference longitude for the time to be kept in the entire country. In case of India, that longitude is 82.5 degree east, 82.5 degree east. So whatever the time is on this longitude, the local mean time, LMT time, local meridian time, that time will be the standard time for the whole country. So irrespective of longitude which passes through your place, you will follow the time which happens on this longitude, that is 82.5 degree east longitude. Okay, and this time will be followed by everyone in India, whether that person is in extreme east or west, south or north. Okay, whatever your longitude, you will follow 82.5 degree east longitudinal time. So standard time is nothing but the time kept by the local authorities for that particular country. Now in this case, the closest option will be local time. Local time in this with respect to this question, local time means the time which is kept in a country locally. Next, a time difference of 5 hours 20 minutes 20 seconds is equivalent to what change of longitude? Now we do know that 360-degree change of longitude is equal to 15 is equal to 24 hours. So to make one full 360-degree rotation, the earth takes 24 hours of time to just make 15 degree of rotation. The earth will take 1 hour. Okay, now we are going to use this identity, that is 15-degree change of longitude equals to 1 hour, and convert this time 5 hours 20 minutes 20 seconds into corresponding change in longitude. Now we know 1 hour equals to 15-degree change of longitude. Okay, 1 hour is equal to 15-degree change of longitude. So 5 hours 20 minutes 20 seconds will be how many change in longitude? So cross multiply, and this gives you an answer of 5 hours 20 minutes 20 seconds that is 80 degree 5 minutes. Change of longitude. 80 degree 5 minutes. Next, question number 5. The reason that day and night throughout the year have different duration is due to what? Why do we have different duration of day and night? Because of seasons. During summers, we will have longer days, shorter nights. During winters, we will have longer nights and short days. So, relative speed of the sun along the elliptic, that is wrong. The earth doesn't move, it is fixed. Inclination of the elliptic to the equator, earth's rotation, gravity. So, correct answer is option Bravo. When your equatorial axis is inclined to the orbit of the earth around the sun, we will have, so look at this. This is your earth, this is the equator. This is Tropic of Capricorn, this is Tropic of Cancer. This is the elliptical orbit of the earth around the sun. Okay, now this equator is inclined to the elliptical orbit by 23.5 degree and 23.5 degree north. So when the sun is over 23.5 degrees south latitude or Tropic of Capricorn, we have summers in the southern hemisphere. So southern hemisphere will have longer days, shorter nights. When the sun moves to the equator like this, as Earth revolves around the sun, when the sun is over the equator, we will have equal amounts of day and nights in both hemispheres. We call that season spring equinox and autumn equinox. Again, when the earth revolves around the sun, there will come a point where the sun will be over Tropic of Cancer, 23.5 degree north latitude. In that case, the northern hemisphere will have summers and southern hemisphere will have winters. So northern hemisphere will have long days, short nights. Okay. So it is because of seasons that we indirectly get longer days, shorter nights, longer nights, shorter days. Okay, so remember option Bravo. Next, question number 6. The sun rises at 50 north, 25 east on 25 January at so and so time. On the same day, what time does it rise at 40 degree west? Now, in order to find time, the coordinates we can ignore. The latitude coordinates we can ignore. Now we have two longitudes given to us, 25 east and okay, so we have 0 degree prime meridian, 40 west and 25 east. Now the sun rises at 25 east at time 0254 UTC. 0254 UTC. We have to convert this time into corresponding LMT, and if you want, or we can just find a final answer in terms of UTC. So what you will do is find sunrise time at 40 degree west longitude. We will have to use D long. Now remember the separation between these two longitudes. The d long between them is equal to how much? 40 plus 25. Different hemispheres add. That is 65 degrees. Right? So sunrise first, it will first happen in the eastern hemisphere. Then the sun will apparently move towards the west like this. Then prime meridian, then some longitude less than 40 west, and finally 40 west longitude. Okay, so sunrise will happen at a later time at 40-degree west longitude, later than 0 to 54. Okay, 0 to 54. So what is the formula? We know that 15-degree change in longitude is equal to 1 hour. 65-degree change in longitude will be equal to how many hours? We do not know. Cross multiply 65 divided by 15. That is equal to 4 hours 20 minutes. So d long of 65 degree is nothing but a change in time equivalent to 4 hours 20 minutes. Okay. So time, the sunrise will happen at 40-degree west longitude 4 hours 20 minutes later than 0 to 54. So sunrise at 40 west will be 0 to 54 UTC plus 0420 UTC. So 2 hours 54 minutes plus 4 hours 20 minutes is 7 hours 14 minutes UTC. 7 hours 14 minutes UTC. Okay. Now let's convert this 7 hours 14 minutes UTC into corresponding LMT time. What are the two meridians you will consider? Prime meridian and 40 west meridian. Let's convert this 0714 UTC into corresponding LMT time. We know that western longitudes will run behind in time compared any longitude which is the east of it. Now in this case 0-degree longitude is to the east of 40-degree west longitude. So what is the conclusion? Local LMT time at 40-degree west longitude will be behind LMT time or UTC time at 0-degree prime meridian. Right? Therefore, now to find LMT time at 40-degree west longitude, you will have, it will be behind in time. Okay. So you will have to use subtraction. So you will subtract, will use this formula. So whatever UTC time is there, from that time you will subtract the difference between these two longitudes, the difference in time between these two longitudes. Now what is d long between them? It is 40 degree. Now you can convert this difference in longitude into corresponding difference in time. You know that 15-degree longitude is equal to 1 hour. So 40-degree change in longitude will be equal to how many hours? So you will do cross multiply 40 divided by 15. that is equal to 2 hours 40 minutes, right? So UTC minus 2 hours 40 minutes. So 0714 minus 0240 is equal to 4 hours 34 minutes LMT. Okay, so LMT time at 40° west will be 4 hours 34 minutes. 4 hours 34 minutes. Next. So number 7. On 27th of February at 52 south, 40° east, the sunrise is at so and so time. On the same day, at same latitude but 35° west, what will be the sunrise time? So, longitudes 35 west, 40 east. Difference between these two longitudes will be equal to 35 plus 40, 75°. This will be equal to time of 75 divided by 15, that is 5 hours. Okay, so UTC time at 40° east is 0243. So UTC sunrise at 35° west will be later than UTC sunrise time at 40° east. This is because eastern longitudes are ahead in time compared to their western longitudes, any longitudes to the west of, to their west, compared to their western longitudes. So the sunrise will first happen at 40° east longitude and then later at 35 west longitude. So UTC time at 35 west will be equal to UTC time at 40 east plus the difference in time between them, which is 5 hours, which is 5 hours. So 0243 plus 0500. So 0743. So the UTC time of sunrise at 35 west longitude will be equal to 0743 UTC. Next, question 8. On 27th February at 55 south, 20 west, the sunrise is at 250 UTC. On the same day at 75 west, what will be the sunrise? So the two longitudes here are 75 west and 20 west. The D long between them is 75 minus 20, 55 degree. The time difference between them will be 55 degree divided by 15, which is equal to 3 hours 40 minutes. 3 hours 40 minutes. So again, 75 degree west longitude is west of 20 degree west longitude. Okay. So UTC sunrise time at 75 west longitude will be later than 20 west longitude. Okay, will be later than 20 west longitude. Therefore, UTC at 75 west equals to UTC at 20 west plus the time difference between them. What is the time difference? 55 degree divided by 15 degree, 3 hours 40 minutes. So 0250 plus 0340, 2 hours 50 minutes plus 3 hours 40 minutes is 6 hours 30 minutes. 6 hours 30 minutes. So the sunrise will happen at 6:30 UTC time at longitude 75 degree west. Next, question number 9. The angle between plane of ecliptic and plane of equator is 23.5 degree. Okay. So if this is, let's say, Earth, this is your equator, this is your Tropic of Cancer, Tropic of Capricorn, and this is the orbit of the Earth around the Sun, elliptic orbit of the Earth around the Sun. So the angle between the equator and this orbit will be this angle, which is 23.5 degree. 23.5 degree. Last question, at what approximate date is the Earth furthest away from the Sun? So when the Earth is closest to the Sun and Earth is farthest away from the Sun. So when the Earth is closest to the Sun, we call that position perihelion. It happens on 4th January and it is farthest away from the Sun. That position is called aphelion. It happens 4th of July. Okay. So the correct answer here will be Earth is farthest away from the Sun in the beginning of July. Beginning of January is perihelion. End of September is autumn equinox. End of December is winter solstice, winters in the northern hemisphere. In the north hemisphere. Winter in the north hemisphere. So we'll stop here. We will do the next 10 questions in the next video lecture. Till then, practice these questions. Practice the RK Bali as well as Oxford questions. I have solved all the questions and uploaded them to my YouTube channel. So do watch them if you haven't. If you have watch them again so as to revise the concepts. I wish you all the best. Subscribe to this channel and share this video with your friends. It will be very helpful for them also. I'll see you.